Hello, everybody, and welcome to the ODPI webinar, Making Data Better. It's a project overview of everything ODPI, and with no further ado, I'm going to hand it over to our host, Mandy Chessel. Welcome, Mandy.
Thank you, and can you hear me okay? Yes, I can see that. Yes, welcome to our webinar. In this next hour, we're going to take you through the 3 projects that are part of the ODPI. The ODPI itself is an organization that is part of the Linux Foundation, and it aims to create open source projects that support data platforms and provide data services to ensure that organizations can make the best use of their data. The way we operate, we have a board that are responsible for the financial health of our organization. And then underneath that, there's a technical steering committee. And this group is responsible for guiding projects and also onboarding new projects into the foundation. We also like to meet once a month to share our experiences in leading our various projects. So today we're going to go through the 3 projects that we have running in the ODPI. The first one is OpenDS for All, or Open Data Science for All. Then we have the BI and AI project. And then finally, we're going to talk about Egeria. So without any more sort of overview, I'd like to hand over to Andre, who's going to talk about OpenDS for All.
Good morning, everybody. My name is Andre de Waal, and I'm the chairperson of the Open Data Science for All project. The Open Data Science for All project was initiated more than a year ago with the aim of developing modules that can be used to accelerate the development of data science curricula and education. Next slide, please. As you all know, there's a severe shortage of data scientists. Now, here in the US and worldwide, there are many data science programs, and you might think that there should be an oversupply of data scientists, but it's not the case. If you think of the big IT companies in the world, IBM, Google, Facebook, Amazon, they cannot hire enough trained data scientists. So although there are more than 250 programs in the US and worldwide, and here we've grouped kind of data science programs, business analytics and data analytics together, there is still not enough data scientists that are being trained and available for businesses to hire. So I heard once that people say a data scientist is like a unicorn, but I rather like the analogy of being a platypus, a data scientist. So they are just very scarce. They are not a mythical figure. So there are data scientists, but we would like to assist universities and companies to accelerate the development and training of data scientists. So there are skills are in demand, and we need to accelerate the development and students that can graduate as data scientists. Next slide, please. So Open Data Science for All is an open source or open curriculum project handled as an open source software project. So it's a first of its kind. So it's a data science curriculum kit built on open source. And for now, we're sticking to Python. Later on, we might add R modules to the curriculum kit as well. So think of the curriculum kit as lessons or modules that can be used as Lego blocks to help you to build a data science curriculum. Now, our partners in the project are the Linux Foundation and University of Pennsylvania, and the original set of 15 modules was built by a couple of professors and a couple of students at the University of Pennsylvania. So it was built by professors for professors. And as I already said, it was launched as an open source project under the guidance of the Linux Foundation to ensure growth of the content that we currently have available. So the goal of the project is to enable organizations to build their own data science educational programs. So this includes any company can use the material because it's modeled as an open source project, or any university, school, and even high schools can use the content. Next slide, please. So at this stage, we have 15 modules or lessons available. Each module or lesson duration is at least 50 minutes, but some of the more complex lessons or modules need 2 or 3 lessons to completely cover. So as you can see from the screenshot, we have 15 modules, and we try to cover the data science process, starting with an introduction to data science. Then there's a module on how your computer works, talking about memory and CPUs. There's a module on data acquisition and data wrangling, which is one of the first steps in the data science process. Very important is data visualization or information visualization. Explore your data with graphs and plots before you start with the fun stuff, the predictive modeling and the neural networks. Then we have a couple of modules on distributed and parallel processing, accessing Apache Spark engine. So these days, big data is very important, also graph processing. And you've all heard of Google's PageRank, designed by Larry Page. So distributed parallel processing on big data is very important. So there are 5 modules around this topic. So scaling to big data in the cloud, cluster-based processing of graph data, efficient data processing, network centrality and PageRank and graph analysis using linear algebra. The next couple of modules focus on machine learning. So currently we have 1 module on unsupervised machine learning that covers principal components and k-means clustering. Then we have 3 modules on supervised machine learning. The first module is an overview, covers decision trees and random forest. Obviously, we need a module on linear and logistic regression. And lastly, we have a module on artificial neural networks. As I already indicated, some of these modules might need a couple of lectures to cover. Then we have a module on training robust models. So once you've built a number of models, you obviously have to pick the best one to put in production. And that's the module training robust models. Then very important in these days of bias in models and algorithms and big data and data breaches, data science ethics. So data science ethics should be weaved through the whole curricula if you design a data science curriculum. Next slide, please. So we are a little bit unique, our project, that we have our own technical steering committee as well. And this technical steering committee is made out of professors from leading schools in the US to ensure the integrity of the content and help us guide the project. So we have David Mongo from Berkeley Institute of Data Science, Susan Davidson and Zach Ives. They developed the content for us from the University of Pennsylvania. Then Eric Lebar, he's a professor at the Institute for Advanced Analytics, the first data science or advanced analytics program, master's program in the US. Gautam Chakraborty is a professor at Oklahoma State University. And then my manager and I, so Anna Echeverry and myself, Andre de Waal from IBM. And then we have James Haroon from SAS Institute. So we have a company contribution, but we are heavy on the faculty seats so that we can, they can help us guide where the project needs to go. Next slide, please. So this is just a screenshot of the GitHub repository. So although it is an open education project, it is run as an open source software project. And therefore, we asked the Linux Foundation to help us to set up the infrastructure. So it's a project created to accelerate the creation of data science curricula at academic institutions. But as I indicated, any company that needs to or wants to upskill their personnel, maybe they have somebody in databases that wants to get into data science, this material can be used to upskill your personnel at any institution because it's available for free and at no cost as an open source project. Next slide, please. So the 15 modules that I described a couple of minutes ago are grouped into categories, and these categories will obviously be expanded and grow as we add more content to the repository. Most of the modules has a set of PowerPoint slides, maybe 1 or 2 sets of PowerPoint slides with instructor notes. I think 13 of the modules have accompanying Jupyter notebooks that illustrate the practical aspects of what was discussed in the slides. And then there are a couple of quizzes, sample homework assignments, and additional documentation if applicable. Next slide, please. So here's just an example. So under the overview grouping, there's an introductory lecture or module on data science, so introduction, data science. We have some keywords, and the difficulty level, it's basic introductory material. So you can search on the content and very easily get to the lectures with covering certain topics that you are interested in. Next slide, please. So here's an example of the introduction to data science. As you can see, very well developed slide deck with instructor notes that can be used either at an undergraduate level or at the graduate level, depending on how you would like to structure your data science program. Next slide, please. And just another example of exploratory data analysis. The second line there is the Jupyter notebook, and then we have a set of PowerPoint slides as well. Next slide, please. Here's an example of one of the Jupyter notebooks, a very interesting one. So it's like the introduction to Jupyter notebooks for students, and it's a data wrangling exercise. So in this exercise, we test the hypothesis that CEOs of major companies are typically in their 40s or older. And this is done by installing your Python packages, importing a couple of packages, then grabbing some information from Wikipedia, so doing a web crawl, merging the data set with a data set of companies, big companies, and then doing some data cleansing. And in the end, we get to a distribution of the age of the CEOs. So next slide, please. So there's the final result, so 35 cells. And as you can see from the graph, most CEOs were born in the 1950s or 60s. So obviously they are older than 40 years. So this is just a couple of examples of the Jupyter notebooks that we have available and the sets of PowerPoint slides. Next slide, please. So a couple of comments. So for the Python code, we use the Apache 2.0 license, and everything else is basically covered by the Creative Commons by 4.0 license. We are planning a first release of the repository as the content is stable, and hopefully we'll get this done within the next couple of weeks. We are currently in incubation stage, but we've fulfilled all the requirements to move on to active stage, and this will hopefully be done in the next couple of weeks as well. There are our communication channels, a mailing list, and we also have a Slack channel. Next slide, please. So what we ask of you is to become involved in the project. First of all, to contribute content modules, and you don't need to be a faculty member if you work in industry or have expert knowledge in a field. And obviously, as you've seen, we did not cover everything in data science. Please feel free to contact me, and I'll work with you in finding a topic that you can contribute content to. We also need committers, so faculty, to ensure the integrity of the curricula. So we currently have 9 members on the technical steering committee, and they are the committers, but in future, the seat on the technical steering committee is only for 1 year. So we would like some fresh blood at some stage in the technical steering committee. And then also promote what you've seen. So we currently have 3 adopters, Kennesaw State University, Oklahoma State University, and then University UNC Charlotte. They are currently using the content in the program, and we are in talks with many other universities all over the world to help them to accelerate the development of their data science programs. Next slide, please. And that is the end. Thank you.
Okay, so any questions for Andre? Okay, so let's move on to Cupid.
Thank you very much, Mandy. So my section is about BI and AI. And as before I move on, let me share with you a story related to myself. I think 2 years ago, there is a conference called Cheetah that is like a conference of healthcare IT and analytics. And one of the questions that was raised to me as one of the speakers in the conference is like, what do I see about the analytics industry in the next 5 years? And the answer I gave is AI plus BI equals CI. So what I mean is like AI, you know what is it about? It's artificial intelligence, and BI, business intelligence. And what is CI? So I explained. If we are going to look closer to AI, that really can help by the speed that machine can contribute in that analytics, which is the machine is very good on the speed and to create and produce the result. But at the same time, BI traditionally is a tool used by human, and not only used, but to review the human intuition very naturally from the BI tool. So I said, if you combine the speed that can be offered by AI and the direction that is very intuitive by the human being, that will become the CI, that is the cognitive intelligence that we all want to seek for the next few years. And believe it or not, after that conference, I get a chance to also lead this Linux Foundation ODPI team. And AI and AI, this is actually one of the projects that, in my vision, we can combine both sides of the best of the both sides of the world to really get the benefit for the industry. So this project is a little bit different than the other project in Linux Foundation in general. Number one, it's not code-based. It's more like best practice and recommendation-based. And we collaborate with the industry leaders in the market to come up with some recommendations and best practice or even standard, so that like people or the readers, the audience of this project or the white paper can really adopt and then apply to their workspace. So those are the difference that may be different than like what Andre has explained. They have the GitHub repository for all the data science code. But at the same time, well, hopefully this will also be a practical project that can help the industry to move forward. So next slide, please. That is the title. So yes, the mission. The mission itself, I think I explained it like by my story, is to increase the interoperability between the BI and also the AI technologies. And one more point for you to note, in case you haven't noticed that, AI is an ecosystem full of open source. And basically you can go to GitHub or any open repository to get the library download and start utilizing that. But BI traditionally is a very proprietary industry. How are we going to open up the black box of BI just to let them talk? It's also something that we would like to, through this BI and AI project, to get them together, to collaborate together so that we can increase the interoperability on these two technologies. And also, as I mentioned, the best practice and also standard is the goal, is the focus of this project, instead of creating the code that can be checked into the GitHub, just like the other project. And of course, like besides the best practice, we want to be practical. We want something that you can utilize it and maybe help you to make the decision when you make a choice on the BI or the AI area. And some of the very interesting fact about this group. This group used to be called BI and Data Science SIG, like a special interest group. So like, but when we look at the trend of the industry right now, AI is a buzzword, and we want to make sure that people is catching this project. So we do have the Open Data Science for All, which Andre has already mentioned that. I think like it's also interesting that we actually take a step away from data science into AI, but we started this project back in 2017. And in 2018 May, we renamed it just because of the reason that I explained. Next slide, please. And in order to like fulfill the very first deliverable in 2017, we do actually have a very in-depth comparison between the two very popular data science notebook in the market, Jupyter and also Zeppelin. In fact, the original author of Zeppelin also involved in this data science notebook comparison and guidelines. We list out a list of different criteria, including what kind of user persona are those two notebooks are target for, compared to the user interface. What is that good for and which one is better for whom? The architecture, and also how is it going to take care of the security as well as the big data ecosystem. So for this very first deliverable back in 2017, we do have a team to come up with this suggestion. You know that it's not one size fit all. Someone would like Jupyter more, someone would like Zeppelin more. So these guidelines will help the users like you to find out what is the best choice for you based on those criteria. Next one, please. So after that, after the like a BI and data science, as we move along, as I mentioned it to you, we enter to the AI area, and that's the reason why we have the second deliverable about big data, but with the BI capitalized. And I think one of the very reason is when we are talking about data. Now, in the past about 30 plus years is relational database or relational data warehouse. All the BI tools are primarily focused on how to get the SQL run it very effectively and efficiently on the RDBMS and get the result out as a BI report. But with big data right now, or maybe starting from 4, even 7 years ago, when big data Hadoop, now is S3 on the blob store, even NoSQL, it's on the market right now to fulfill different nature of the data in the market. How are we as a BI leader, how are those vendors or technologies trying to accommodate those different types of data besides RDBMS? In the second deliverable that we had back in 2018, we had a chance to work with, you can see that on the screen, SAS, Click, MicroStrategy, IBM, and also Tableau on their BI tools and platform. What is the secret sauce that they use in order to make the BI platform also be effective on other data storage mechanism besides the RDBMS? That's the focus on this second deliverable. I think even though it's almost 2 years from now, but when we're talking about big data and BI, this is still a very comprehensive guidelines for you to go back and refer. Next slide, please. The very latest one, I think this is also one of my favorite about the deliverable for the BI and AI, is about BI Endgame, when BI meets AI. And this actually happens for another conference that I was the speaker, which I explained in the beginning of my talk. I explained, hey, BI is dead. And as you can imagine, in a BI conference, as a guest speaker, when I say that, there was actually a 5-second silence, but I continue. I said, BI is ending, is dead, unless you incorporate AI into the platform. And by incorporating, what I mean is twofold. Number one is you need to incorporate the AI capability to enable the BI platform. So for example, instead of building up a report by dragging the attribute or the metrics to a report, how about you use AI and natural language processing by just typing your question, and the BI platform can automatically formulate the report or dashboard for you. So that's one end, one side. That is like your BI platform will be enhanced by the AI technology. But on the other hand, the BI platform should also enable the end users to incorporate AI. So for example, the supervised and supervised learning that Andre has already mentioned in his talk, how are we going to enable that into the BI platform that is already very familiar by the users? Can they open this up and instead of just creating a report, but enable the AI algorithm in the BI platform? That is another angle of when BI meets AI. In fact, in this white paper, you can see that some of the vendor start contributing to Linux Foundation ODPI since 2018, but we do have some new leaders in this market like ThoughtSpot and Microsoft also come into this picture and try to brainstorm what would be the best way and the right way to incorporate AI into the BI platform. And in fact, if you count this, minus me, there are 6 participants in this white paper. And what a coincidence that, like, if you remember last year, 2019, the Endgame, the Avenger Endgame, it was one of the blockbuster in movie. And I actually find a way to match up the 6 stone, the Infinity Stones, to each of the vendors here. For example, I would say Power Stone, it belongs to Microsoft, not only because of their Power BI, but the already familiar Office infrastructure or the Microsoft infrastructure has already been familiar with the users and now empower the user to do more. For example, another example is MicroStrategy. I correlated to the Space Infinity Stone because of the unique architecture design by unifying all the data sources, even though it's multiple data sources, effectively into one centralized location to teleport all those data source into that area, into that one thing. So without a Bifrost, you can actually shorten the analytics journey. So if you take a look at this white paper, you will see like this kind of analogy keeps on going on this analysis. So I hope if you have time today, I'm not going to go through all the 6 stones, just to leave some homework for you to go to the white paper and see them all. But the fact is, if you are going to contribute to this project, you'll be able to work with different BI leaders or even AI leaders to do something very interesting and then practical to the industry trend. Next slide, please. When we're talking about practical, when we're talking about industry trend, I think the bridge that we are trying to build for this 2020, which is the current project and deliverable that we're working on right now, is definitely some of the very big milestone that we want to achieve. When we are talking about the bridge between BI and AI, we brainstorm a lot of different options. One, for example, is how about we can build a bridge so that this bridge can spawn a child process to call the underlying AI framework, for example, TensorFlow, PyTorch. But on the other hand, on the other end of the bridge, it can also review the result of that AI process. For example, when it is in a training process, what is the progress right now for the training? We can expose it into the BI front end. That is one way to interpret the bridge. Another way to interpret the bridge is how about like treating the bridge as machine learning and machine teaching. And what I mean by that is in the past few years, we talk a lot about AI and machine learning, which is how to make the algorithm more effective and more accurate by utilizing the data. But we somehow miss the point of the feedback loop, how the human as ourselves to teach the machine. If you're thinking about the schooling system all over the world, learning is not just learning. Learning is the student part, but you still need the teacher to teach something. So the idea for this option is to focus on human-centered AI. How are we going to balance the machine learning and also balance the machine teaching to make the AI ecosystem more balanced? So that's the other option. Of course, like some people may say, hey, the bridge maybe it's between the mechanism to handle the administration and also the training and the result. How are we going to bridge them, the administrative task and also the actual training and the prediction of the result? That could be another bridge, right? And how about the bridge across different user communities and also persona? So think about the data scientist focusing a lot on the hardcore algorithm. How can we bridge them to the business analyst so that they understand under what circumstances on which business scenario I should use what kind of algorithm or machine learning like method to do this kind of analytics task. Those are also another bridge that we brought up. But last Friday, like hot from the press, we have already voted that like the winner for the bridge that we are trying to build for the rest of the 2020 is the human-centered AI. How are we going to bridge the like machine learning part and machine teaching part to make more the AI more human and introduce more human intuition to that? I think that aligns more to what the BI and AI group would like to achieve as the mission. And at the same time, I think like for those who are listening to this webinar, if you're interested, I think you can also contribute it, which guides to my very last slide, Maddie. If you want to participate, please like you can connect me with Twitter or LinkedIn, or just join the email group as the URL is listed here, so that we can start engaging you to the rest of the group, and then we can work on the rest of the 2020 deliverable as I just mentioned to you. And in the future, in 2021, the hope is we can convert this like a theoretical like approach into something that we can really code and accumulate it in a code base in GitHub, so that it's not only some guidelines, but also it's something that the industry can use it right away. So that is my last slide, and back to you, Mandy.
Thank you very much. Any questions for Cupid? I can see two. I can't see the questions as I'm sharing the screen. Okay. So let's move on to the final project, and hopefully there'll be some time at the end. The final project is Egeria, and this is providing support for something we call open metadata. And I'm going to hand over to Marina to take us through the project.
I was wondering, Mandy, do you want to introduce yourself so we can pick up later in presentation, and then
Yes,
I'll do...
okay, all right. So, so yes, my name's Mandy Chessel. I'm the lead of the Egeria project, but the project itself is really a fairly active community, and so a lot of my role is you know, is made very easy by the fact that I have such a fantastic community supporting the project. So that's me, Marina.
Marina Strelchuk. I'm information architect and contributor and maintainer for Egeria project. Also been with the project, I think, since the very beginning, from the drawings on the walls to now a full-fledged, really, big project with a lot of functionalities. If we go to next slide. I would like to start with looking at the overall status of Egeria project. And as we said, well, it's an open source project under Apache 2.0 license. And as such has quite a big community. We have 56 contributors, and they come from different companies where we do our day-to-day job. So that's a really nice aspect, but also it's a very versatile community. So you would have people whose, you know, main focus is to develop a feature to actually produce code. But we also have designers and architects who help with, you know, creating a bigger picture and how all the moving pieces are together. People who are focusing on the user experience and developing UIs for Egeria. So it's a big and growing project. Very proudly, we have more than, I think, 16 million, it says, lines of code. So it's very also active, as Mandy mentioned. A lot of requests, a lot of interest, wishing a bigger community to keep developing it. And if we go to the next slide and we look at Egeria from a little bit of an external view, and then we think about organizations that are striving to be truly data-driven, it is very important to have a proper level of collaboration between different teams and experts. And in big organizations, you might have a number of different areas of expertise. You might have governance teams that focus on developing and formulating strategy, policies, and rules. You can have data owners, asset owners, and stewards, where the knowledge about where the data is, what does it actually mean, what business meaning it has, and how you're supposed to treat it and for which purposes resides. Then you have architects who help create the bigger picture and see how the components and different tools work together. And you have business users who are using different platforms and who actually needs to be able to be enabled to make data-driven decisions. And because of this, different teams and experts and different tools that they are using, the number of these tools that come from different vendors and have different focuses is quite big. And these tools are the places where we usually have the knowledge about the data, and we refer the data or knowledge about the data as metadata. And there is a need to link the knowledge that has been created by one group of experts and make it available and be linked to another group. And that's where the open metadata standard comes into place. And this is a standard that enables different tools to be connected and exchange metadata. And ODPI Egeria is actually a project that makes this standard a reality, something that you can install and run and have it not only nicely on a picture. So in this next slide, it's a bit different view on where open metadata or Egeria finds place. You can think about it as having data on a bottom level, and then having these metadata repositories, so where the knowledge and description and rich attributes about the data is residing. And on top, we have the different groups of end user tools that are focused on consuming and also producing metadata. And Egeria creates here peer-to-peer protocol between repositories and provides common language and set of exchange protocols that allow for these metadata repositories and tools to talk to each other and exchange and consume metadata. Now that's a very short idea of what is the main purpose of Egeria, to enable this exchange and widely accessibility to this insight about the data. And on the next picture, we can see that's the true value of Egeria. It enables the collaboration between the teams. It actually allows business user to find the data that they can use to make their decisions, to be data driven in the end as an organizations. So availability is addressed, but also it's breaking down the very typical traditional silos of security in a data and applications. So here's the value of Egeria. And when we look in the next slide on the complex topology that the most enterprises have, we can see that they need to operate in highly distributed multi-cloud and multi-platform environments. And in these environments, we want to use open metadata standards, and hence Egeria needs to be able to work across these highly complex environments. And here, on the next slide, is where peer-to-peer distributed protocol comes into place. Because in these complex architectures and topologies, you cannot have one single physical repository that is the knowledge of everything. And with these peer-to-peer distributed protocols, Egeria provides the integrations between different tools and different sources of insights and knowledge and metadata. And this allows users and tools to feel as if there is one singular view on metadata, when in reality, they can be sitting on separate edges and separate environments. And on the next slide, when we think about having Egeria in operation and deploying Egeria in these distributed environments, you can think of each of these environments as being a separate kind of grouping or green cloud in this picture. And when we deploy Egeria, you would have one or more platforms sitting in this cloud. And then you will run servers, one or many servers. And these servers will focus on supporting specific type of tools. So what you would typically do is look at your landscape, look at number of tools and what kind of types of tools you have and you need to integrate. Then you would match them and to specific type of servers that supports them, and you will know what exactly you need to run on the platform. Then, depending on the servers, Egeria will know how to organize the environment and set up the exchange between different pieces. So this is basically done by Egeria for you, and you don't have to do all this work on your own. Now, on the next picture, when we talk about most of enterprises working in complex distributed environments with different range of operating environments, some of them could be set up in a centralized cloud environment with, for instance, high availability requirements. And hence, Egeria server will be sort of stretched across different platforms. And in this way, you can do, for example, the rollout of upgrades, or even the migration to different system. And also you can satisfy things like disaster recovery. Or you might be a smaller team that has various requirements for different kind of tools. So you'd have one platform, but a different number of servers running, and support for multi-tenancy. Or even totally different example of having very small edge node that can have small platform and one Egeria server. And when I say small, it is as small as Raspberry Pi. And on Raspberry Pi, you can even run Egeria platform. And I believe we did it as one of the demonstrations at the lab at one of the conferences. So Egeria will have a platform that hosts all the integration technologies and could be configured for different purposes in different ways, from as small as being able to run on Raspberry Pi to big multi-cloud environments. And we're using the same technology, but it is that the way we configure it is altered. And on the next slide, we can have a closer look at different kinds of servers. So I mentioned already that we have platform and there are different servers depending on what kind of functionality is needed. So in darker color, the orange color here, we have the representation of different types of servers. And then they are organized in the hierarchy, which determines a bit on how they are configured and how they are operating and where will they sit in the architecture picture. So the first group, cohort members, and by cohort, we mean, well, this is a concept that we use to group different tools. They need to be aware of each other and exchange metadata. And they can join the cohort and they are visible to each other. So cohort member has servers that need to connect to cohort to exchange metadata between each other. Then we have a governance server, and they integrate and manage a bit high level types of governance. They sit outside the cohorts, so they themselves don't join the cohort as a full-fledged member, but they connect to the cohort members. And another type is a view server. And view servers support various UIs that are then facing the end users. And back to you, Mandy.
Okay, so from what you can see, the Egeria technology is very modular, scalable, and highly connected. And we thought that it would be nice to show an example of the types of things you can do once you start to connect your tools together. So this was a use case that one of our first use cases was really in a big data lake. Is it possible to automatically configure the access point that people use to pull data so that as new data arrives into the data lake, data scientists can access it, but there's a mechanism to allow every request to be intercepted and scrutinized, and things like masking and filtering occur depending on who the user is. Now, you could do this all manually. However, that is very expensive when you consider a very large data lake. So what we're showing here is an example of 4 of these, well, actually 5 of the servers that Marina was talking about, configured together to actually create this automatic building up of the access point for the data lake. And we call this scenario the virtual data connector. So what's happening if we start over on the left-hand side, you'll see that there's an integration daemon, which is one of the governance servers that is constantly polling a database server or listening to changes to files on the file system and extracting the information, all the information it can about those new data sources. They are then pushed to what we call a metadata access point, which is metadata, which is a server that is connected to the cohort, so it can talk peer-to-peer to all the other servers that are connected to the cohort, and is pushing that information out and sharing it with all the other cohort members. One of them is the metadata server, and that's listening and saying, ah, interesting, new metadata, I'm going to store it. So here we're building up knowledge, we're building up basically a store of metadata that's coming in from the integration daemon. And then there's another server, the second metadata access point, and it's listening to this new metadata and saying, oh, new database, I need to publish that to my integration daemon, which is set up to push, to use the definitions of the new data sources coming in to create a view in a data virtualization engine. That itself is a data source, and so we are also listening for the metadata which about the new views that are being created, and then they come back into the cohort, and then are the things that are visible. So when people are searching for data, they won't see the original files, the original databases. They will see the views that have been created for the data virtualization engine. They click on the view, and now they see the data, but it's been passed through that extra security filter before they need it. And this entire operation is automated because Egeria is able to connect different types of technology together and orchestrate the sharing of that knowledge. Most of what we do with Egeria is the infrastructure. So we have a lot of investment in our frameworks, connectors, and the ability, that very flexible and robust protocol that connects our systems together. However, it's becoming more and more important to also be able to visualize what's going on in that distributed ecosystem. So we've been increasing our investment in our UIs, both to be able to browse what's going on in this distributed environment, but also to start to understand and govern it as well. So this is an example of one of our UIs called the Repository Explorer that allows you to look at all the metadata as if it is stored in a single repository. In our time working with Egeria, we've worked with a number of different vendors, and they have different reasons for wanting to work with us. So in one case, a company had an old platform and a new platform, and with Egeria, they were able to connect the two together and help their customers migrate their metadata from the old platform into the new platform, or to run the two in parallel. Or it might be that a particular vendor's product has been deployed in many places within the enterprise, but they're separate silos, and the enterprise wants to bring them together. And again, Egeria helps in that process. It may be that a vendor wants to be able to pull metadata from lots of different places, but there's a lot of cost involved in building the connectors and the integration technology, and so with Egeria, all of that cost is moved into open source. Again, this might be able to extend the ability, to access new types of metadata through Egeria, and also the ability to push metadata from a governance tool out to the technologies that that need to be governed. So there are many different reasons why vendors are coming to Egeria. And this interest seems to be accelerating. And so the way that the community works and its ability to scale is extremely important to us. So we have always worked in a very open manner. We do all of our code development through the public GitHub. And so when you look at our code, you will see each module is in a different state of operation. We like to incorporate people from different companies, cultures, backgrounds, levels of experience, because it's that rich set of collaborative insight that really has enabled us to build something that has never been built before. As I said, everything we do is on GitHub, and you can see the activity and the enthusiasm through what is effectively our shop window, or maybe it's the window on the factory. Maybe that's the right way to think about it. You can also join us. We have 2 calls a week, both on Thursday, one in the morning UK time, and that's because most of our contributors are in Europe. And then we have one in the afternoon for anybody to join, and there we do demos, we talk about the project, we talk about future ideas and different types of use cases. So that's for sort of almost a consumer's view of the project. There are many achievements, and basically we are releasing a new set of capability that opens up new horizons for how metadata can be managed, but it also creates new challenges, because the original breaking down, the siloing effect of all the different disconnected tools did mean that certain knowledge was isolated to specific groups of people. And as we connect them together, we've had to build a security layer over the top that handles the fact that metadata actually could be more valuable than the data it describes. And certainly knowledge that the metadata needs to be carefully secured, just as any other type of data. When you look at what we're doing, this sort of box diagram is really showing all the pieces that we need. It's not just enough to provide that integration capability, but we also need to provide education. We need to make it easy to deploy, and support organizations through the process of making the most of all their data and digital resources around it. And the way we've been building things up is through a monthly release cycle. So as I said, when you look at our code, you will see there are some areas that are extremely strong, robust, and have been through some pretty major testing and exposure to production environments. And then there are other pieces that are in development. They are experimental and things like that throughout the project. And if you look at what we call the RAG chart that shows red is not started or more of a concept, through to green, which is that it's in a usable state to download and run. You can see that we've been working based on the core platform that enables the integration, and we are gradually building up to a point where you can use Egeria as your metadata capability, but also as your control point for a lot of your tools integration. And the things that we're concentrating most on at the moment are lineage, which is very, very popular, integration of different types of technologies, and the ability to operate it effectively on Kubernetes. All of these pieces are also accompanied by further investment in our user interface. So that is Egeria. And so I will pause now for questions, whether there are any outstanding. I can see 4. So I've got a question here about Egeria. Does this concept extend to open data, or at least to common schemata? So yes, it is. So there's two parts to this. Firstly, we built the type system for Egeria using many different existing standards that are available around metadata. And the reason we didn't use the standards directly is that they're all very narrow. So what we did was stitch them together to create the open types. And then our whole architecture of Egeria is actually to provide points for translation of metadata. So we are pulling in from different standards, different vendors, because most metadata management is using proprietary formats. So we need to be able to extend and we need to be able to translate, basically. So that's really how that works. I think I've got the So that's that. And like the question I don't know how to understand. I wonder if the extractor is using a connection along the lines of a secure gateway technology. I'm not sure in what way that is. I'm not sure how to interpret that. I need a bit more information.
And we can take that one offline, Mandy.
Yeah, I think so. Maybe that's something for the Slack channel.
Yep.
Okay. So any more questions? All right, then I think we have finished for today.
Awesome. Thank you so much, everybody, for joining us. Thank you to all our amazing speakers. Thank you for everybody who joins us. This will be up on YouTube soon. And have a great day.